Jai Jandar, Namaste, welcome to my channel. Today we are going to solve the 24th question of the problem solving series, which is based on arrays. So let's begin. Maximum product sub array. This question has been asked in Amazon, PayPal, Microsoft and multiple companies, and the difficulty level for this question is medium to hard. So let's begin. So we are given an array. We need to find the sub array whose product is maximum. So in this example, so 6 minus 3 minus 10, 0, 2. So the product of sub-arrays, right? We know what sub-array is. So if we take the product of 6 and minus 3 is minus 18. It's a negative number. If we take the product of all these three, then it is minus 3 into minus 10 is 30, 30 into 6 is 180. And now it's 0. So it would become 0. So we can't go beyond it, including this, otherwise it would become 0. So definitely the answer is 180. Here in this example, minus 1 into minus 3, 3, 3 into minus 10 is minus 30. So and then again 0 comes, so minus 30. So if we exclude minus 1, then it becomes 30. And we have 30 over here, and if we multiply it with 0, then 0, and then it's 60 over here. So our maximum product sub array will actually be 60. So how do we solve this problem? We have solved it manually. Normally, if anyone gives this example, he'll solve it directly. But how did we actually solve it? What did we observe? What are the different kinds of test cases that we can have? So we need to think of the test cases, all the edge cases, so that our code solves all the issues. So we have seen that whenever we reach 0, if we multiply any product with 0, obviously it is 0. And then if we include our sub-array, including 0, then it would be 0. So we need to maximize our product. So we can't take 0, right? Also, we see that when the elements are positive, then if we include the whole array, suppose the sub-array is 1, 2, 3, 4, 5. So if we include the whole sub-array and multiply it, it obviously would increase, right? So we'll take all the elements. The sub-array will be the maximum sub-array, right? So this is the second observation. What is the third observation? If the numbers are negative numbers, so here if the number is negative, so we have multiplied these two numbers and then it has become positive. Here in this case, we have multiplied minus 1, minus 3 is 3, but when we come to minus 10, it becomes negative. So these are a few observations. So what is the first approach that comes to our mind? Normally we have solved contiguous subarray, right? Contiguous sum subarray. So similarly, this is a contiguous product subarray. So the first thing is, we can, since it is a subarray problem, so we can just take every subarray and find its product and see whatever it is maximum, we can return it. So it's normal brute force approach, right? So we are here 6, so the max is 6, then we go to minus 3, minus 18, minus 10, 180. Like this we do for 6, we do for minus 3, and whatever is maximum we return. So it's a double traversal of loop, so it will be order of n square. We can solve the problem easily in order of n square times complexity, but obviously we need to optimize our problem, so solution. So what do we then do then? How can we optimize this? We have solved the Cardan's algorithms. So the maximum contiguous sum subarray, the 6th or 7th question in this series. So in that Cardan's problem, if you have not looked at it, please go to that video. And then there you can see that how did we use Cardan's algorithm? Can we use it for this problem? Yes, one of the way we can solve this problem is by using Cardan's algorithm to optimize it. What can we do? So in Cardan's algorithm, we had a max and maximum sum and then max so far. So we used to find the maximum sum every time, and we used to get the maximum sums and max of maximum sum and the current sum. And if the sum becomes 0, then our maximum sum becomes 0. We'll start again. So similarly here, we can have 3 variables, and we can find the current product's current value. So for example here, every time this is 60. So our max will always include the current value, whatever is the current value, because the previous value can become 0 anytime, right? And we'll have the max value anyways. So one part it would be this max of AI, and the second part will be the previous values, whatever previously we have stored. So those values we need to take and see whether this value is obviously could be lesser than greater than the current value, right? So we need to have a value here, but in this case we have our minimum value can always turn to become maximum, because negative is you see 6 minus 13 is minus 18. So when we reach minus 10, it actually becomes more. Earlier our max value was 6. Then when we go to this minus 3, it becomes minus 18. So our max value is 6 now. And our minimum value is minus 18. And our current value is minus 3. But when we go again ahead, what happens? Our current value is minus 10. Our previous value is, max value is 6. And minimum value is minus 18. But when it gets multiplied with minus 10, this becomes 180. So we need to keep track of the minimum value also, because if the minimum value is a negative number, then if it is again multiplied with another negative number, then it actually becomes the maximum number. So this way what we will do, how we will implement Kadane's algorithm in this max product subarray, that we will take prod 1 and say prod 2 both equal to 0, and we will have a result. Okay, result is 0. Now we will have a temp value also. Okay, so that we can again assign temp's value to prod 1. Okay, temp is 0. So now when we traverse this for I equal to 0 to n, what we do, so the temp would be a max of AI current value, then the previous value prod 1 into the current value, and prod 2 into the current values. Okay, whenever it will be multiplied, it's like prod. This is the temp. Okay, and we will have always have a minimum value stored. Okay, so prod 2 will store the minimum value over here. So prod 2 would be minimum of, we'll have a minimum value because minimum can always become a maximum next time. So prod 2 would be prod 1 into AI and prod 2 into AI, right? And then we will assign prod 1 to temp, so that we have current value of prod 1, and our max result would be max of result comma prod 1. Okay, and this will give our answer. So in this way we will implement Kadane's algorithm to solve the maximum product subarray in order of n. Okay. So the link to the question has been given in the description. Please try it yourself and then come to the code walkthrough section. Here's the code walkthrough section of this maximum product subarray question in lead code platform. So we have used the same pseudocode over here. We have this max so far. We are returning the max so far. We have used this Kadane algorithm and we have solved this in order of, and now this is the optimal approach, and let's submit this. So yeah, it's accepted. So let me know in the comment section how was the explanation, and see you all in the next video where I'll be explaining the 25th question. Jai Jayendra.